everyone, this is the unit 4 in predictive analytics. In this video we are going to learn about all the topics. Okay, let's see one by one. Here in unit 4 I am going to explain clearly about neural networks, support vector machines and k nearest neighbor also. I am not starting from fitting neural networks. I am going to explain these three because these three is important algorithms in machine learning and in predictive analytics. First you should learn about these three. They ask about each individual question, you should write it right. So I'm going to explain this all also. Neural network, support vector machines and k nearest algorithm. I'll make 3 separate videos for each topic. Please do watch. And if you want anyone up to unit 3 notes, please message me in Instagram or in Telegram channel. I'll provide the link in description. Okay, let's see one by one here. First, neural networks. Okay, what is neural networks? Neural networks inspired by the structure and the functionality of the human brain. Okay, this neural networks is inspired by what? Structure and functionality of the human brain. Are a class of machine learning models that excel at learning complex patterns and representations from the data. Okay, this neural network is inspired by the structure of functionality of the human brain. Same, it works like a human brain and it's excelled learning complex patterns and representations from the data as our brain does. Okay, they consist of interconnected nodes known as neurons organized into layers. This about neurons and layers I'll explain in next slides. This consists of interconnected nodes. Okay, neural networks are a functional component of deep learning. This is a fundamental component of a deep learning and a subfield of machine learning characterized by the use of deep architectures with multiple layers. Okay, let's see how. Key concepts of the neural networks. First one is neurons. What is neurons? Neurons are the basic building blocks of a neural network. Each neuron processes input data and produces an output. Here in neural networks we have a neurons, each layer, that means each has a input data and output data. Okay, layers. What is layers? Neural networks are organized into layers including an input layer, one or more hidden layers and an output layer. Mainly in neural network we consist of 3 layers, that is input layer, one or more hidden layers and output layers. Okay, the input layer receives the data, hidden layers process it and the output layer produces the final result. Okay, next, weights and biases. Weights and biases are the parameters that the neural network learns during training. Okay, they determine the strength of connections between neuron and affect the output. It means we'll give an weight to the each individual neural network layer. Okay, activation functions. What is activation functions here? Activation functions introduce non-linearities to the model, allowing it to learn complex relationships in the data. That means in activation function we allows it to learn complex relationships also. Okay, common activation functions include sigmoid, tan and rectified linear unit, RELU. Okay, this all is not required, you just learn about neurons and layers and weights and biases. Okay, let's see next. Feed forward and back propagation. What will happen in feed forward and back propagation means in the training phase data is passed through the network in a feed forward manner to make predictions. The back propagation algorithm is then used to adjust weights and biases based on the error, optimizing the model. That means in the training phase what will happen, data is passed through the network. Through the network the data is passed in a feed forward manner. That means next each layer is going to compute the next by next. That means one by one. So feed forward means next manner to make predictions. The back propagation algorithm is then used to adjust weights and biases based on the error, optimizing the model. Okay, next, loss function. The loss function measures the difference between the predicted output and the actual target. Okay, during training the goal is to minimize the loss, guiding the network to make more accurate predictions. That means in the loss function it measures the difference between the predicted output and the actual target. I also explained this loss function in unit 3. And next, deep learning. What is deep learning here? Deep neural networks have multiple hidden layers, enable them to learn hierarchical representation of data. This deep learning helps in learning a person by using hierarchical representations like decision trees. Okay, this depth allows them to handle intricate features and patterns. What are the types of neural networks here? Different architectures caters to various tasks, including convolutional neural networks, CNNs. This CNNs is for image related tasks, and a recurrent neural network for sequential data, long short term memory, and gated recurrent unit networks for improved handling of long range dependencies. Okay, these are the key concepts of the neural networks. And next one is applications. What are the applications of neural networks? Image and speech recognition, natural language processing NLP, medical diagnostics, autonomous vehicles, and financial forecasting. Okay, in this applications, image and speech recognition, we use neural networks have achieved significant success in tasks such as image classification, object detection, and speech recognition. Next, natural language processing. They are widely used in language related tasks including sentiment analysis, machine translation, and text generation. Medical diagnostics. Neural network contribute to medical image analysis, disease diagnosis, and predicting patient outcomes. You know what will autonomous vehicles will do in the field of autonomous driving? Neural networks play a crucial role in tasks like object detection, path planning, and decision making. Next, financial forecasting. Neural networks are applied to predict stock prices, analyze market trends, and model financial data. These are the applications of neural networks. Let's see an example for these neural networks. Example, virtual personal assistant speech recognition. We generally in our daily lives we use a personal assistant speech recognition like Apple, Siri, Amazon, Alexa, or Google Assistant. Okay, with this what we'll do by using the neural networks, let's see. Imagine using a virtual personal assistant such as Apple, Siri, Amazon's Alexa, or Google Assistant. These virtual assistants employ neural networks, particularly recurrent neural networks RNN and convolutional neural network CNN for speech recognition. I have told that RNN and CNN is used for speech recognition. How it will be performed, let's see. First, you should give an data input. You activate the virtual assistant by saying a command such as Hey Siri or Alexa. Okay, to turn on the virtual assistant, you just say a command that is Alexa or Hey Siri. And next, neural network processing. What will happen in this neural network processing? The neural network within the virtual assistant system processes the incoming audio data in real time. The network has been trained on vast data sets containing various spoken phrases and words. Okay. Next, feature extraction. The neural network extracts relevant features from the audio data, capturing the nuances of your voice, assistant, and speech patterns. Recurrent neural networks are particularly effective in handling sequential data like spoken language. Okay. After giving your input data, it will process, and next it will check the feature extraction, and next pattern recognition. The neural network recognizes the pattern and converts the audio input into a sequence of words or commands. This involves complex computations to understand context, syntax, and semantics. Next, it will recognize what is your input and what you are going to ask to the voice assistant. This will analyze by using the pattern recognition. Next, command execution. In this command execution, based on the recognized speech, the virtual assistant executes the corresponding commands. For example, if you say, "What's the weather today?" This is your command, this is your input. The neural network interprets the query and triggers the appropriate response by fetching real-time weather information. Okay. Continuous learning. Neural networks in virtual assistants are often designed for continuous learning. As users interact more, the neural network adapts to individual speech patterns, accents, and performance and preferences, enhancing its performance over time. That means it will continuously learn and continuously respond to your queries. This example illustrates how neural networks and speech recognition applications have become integral to our daily lives. Okay, the technology enables natural and seamless interactions with the devices, showcasing the power of neural networks in understanding and processing complex patterns in the real world scenarios. Okay, thank you.